Okay, I'm just muting my video because I get distracted when I see myself talking.
Yeah.
Sorry about that. Okay, thank you again, Brent, for having us, and good to see you again, Dr. Bird. I think this is actually going to be a great reflection for us to just kind of take stock of what we've been doing over the last year. For everyone who will be viewing this later, Cary, Milushka, Dinuka, and I all participated in a critical data visualization workshop last summer, as Brent discussed, and I think that gave us kind of like a springboard of how to just broaden how we look at our research and data analysis in general. Instead of just writing for these academic journals and these research-based audiences, we can think about how do we make our results more applicable or more digestible to practitioners, especially in areas of education and social science. So one thing that I really liked about this project is that we did get to kind of lean on each other's cultural differences and academic differences to kind of just like think about how to explore these different research questions. And I think it's been a really cool experience so far. So our topic is cross-national exploration of secondary math teacher preparation. And so basically that just means we're looking at different countries and trying to ascertain different insights that we can gather from how they approach teacher preparation and possible implications for student achievement. And today we're basically looking at that through the lens of a descriptive discriminant analysis, which is a multivariate procedure that I'll talk about in a little bit, and then also some Tableau visualizations as well as visualizations produced in R. And so I'll kick it off with that multivariate analysis. Milushka is, I'm sorry, I wanted to also say that Cary I met through my hierarchical linear modeling class at UNT, and then we also worked together in our structural equation modeling class. So I just got to learn a lot about her background and expertise as well, and she's been a critical member of this team as well. So that's kind of how we all came together. All right, so without further ado. Okay, so Brent basically introduced us so far, so we can kind of move quickly through this. My interest is in multi-level modeling as well as anything to do with the general linear model. And so this project gave me the opportunity to kind of hash out different ways of exploring teacher preparation data. And then everyone else can kind of say a few tidbits. And Cary, do you want to go first? I think you're muted.
Okay, thank you. Yeah, so I'm a third-year PhD student with the Information Science Department, focusing on data science. So my personal interest is really into educational data mining and how to improve the current use of educational data mining with measurement principles to better understand and support students' learning.
I don't know if I'm unmuted.
Yep.
Hi, I'm Milushka, and I'm a PhD candidate at the Graduate Center. I'm interested in mentorship, STEM. I'm also interested in research literacy in undergraduate students. And my contribution to this project was kind of the qualitative data insights. And I'll talk more about that once my turn comes.
Hi, so I'm Dinuka, and I'm a PhD candidate in applied physics, kind of like outlier from the group, but still I've been interested in working with data mining and data science techniques in scientific data collection. So it's really glad to join this group as a STEM major PhD candidate to work with all these other members.
So we're thinking, since we have all these different chunks of information that we'll be presenting today, that we can take questions after each chunk to keep it organized, or we can take them at the end, whatever works for you all. Okay. So our big picture research question is, why are United States students underperforming when it comes to these international assessments in secondary education? We have two popular international assessments that are used in a lot of educational research. One is the TIMSS, which is Trends in International Mathematics and Science Study. And so this assessment focuses on curricular-based knowledge. It's more curriculum-oriented than the PISA, which I'll talk about in a second. And you'll see at the very bottom of the left table that the average performance on this assessment for 8th graders is a 493, but United States is only slightly above that and is outperformed by Canada, China, Singapore, Russia, Korea. And so we're thinking about, why is that happening? We know there are several differences across all these different countries, but we want to kind of delve deeper into that. Then you look at the PISA results. So this is on 15-year-olds across the country as well, and it's a different sample. PISA stands for the Program for International Student Assessment. And then here you see the United States is actually below average. What's interesting is that these tests are different qualitatively. So the PISA focuses more on real-world application, and we see that's where the United States was falling short. And so again, US is outperformed by Canada, China, Japan, Singapore, Lithuania, and it goes on. So we presented some of this data in Austin earlier this year at the T-STEM conference. And one thing that some of the middle school principals were talking about is the fact that the sampling for each of these studies is very different. So a lot of the times, by the time you get into, I guess what would be 10th grade, in a lot of countries, you had to test into that school. So it's not as representative from country to country as it might be in the US. So that's something to also keep in mind. So for this study, we all were interested in the idea of secondary math teacher education, because that's something that kind of brings us together as a group. We all either have education or science backgrounds, and it's something that if we're to look at a data set of variables, we all kind of understand what's happening. So the data set that we used for the study is the MT21, which stands for Math Teaching in the 21st Century. And we got it through the ICPSR repository, which is where you can find a lot of public data sets for research. One disadvantage of getting data sets through that repository is that some of it is a little bit older and has already been published on quite a bit. But this one did not have as many publications, and we started to learn more and more about it as we worked with it. It is a bit older. Data was collected around 2005, 2006. And another disadvantage, that did not have student outcome data associated or linked to future teachers who were the sample in the data set. So all of the outcomes that we looked at in this data set had to do with what future teachers reported in the survey that they filled out. So the researchers here came from 6 different countries, and that includes Germany, Bulgaria, Mexico, Taiwan, South Korea, and the United States. And so at each of those countries, data was collected at the institutional level. And what we found also is that the sampling was not, I guess you could say, it was non-random sampling, so we have to limit some of the generalizations that we make later on. Most of the variables in this data set focused on teacher preparation, teacher attitudes and beliefs, and knowledge in relation to secondary math education. Okay, so the first type of analysis that we're looking at is descriptive discriminant analysis. And basically, you'll see to the right, there's an equation there that might look familiar if you've taken an intro to stats class before. Does anybody have a sense of what that resembles? Multiple regression, you're right. So because descriptive discriminant analysis is part of the general linear model, you basically have a set of standardized weights that are yielded that you can use to multiply against those different predictors or factors that are part of your study. And so descriptive discriminant analysis is good in working with naturally occurring groups. And the idea is that you can examine group differences on a set of continuous outcome variables. So I have my categorical grouping of countries, and I'm able to see how are countries differentiated across these different outcomes. One benefit of this is similar to what you might find with MANOVA, which is a multivariate form of ANOVA, when you're looking at categorical influences on outcome variables. But with MANOVA, you have several different outcomes that you're analyzing at one time, is that you're minimizing type 1 error. So you're minimizing the chance of rejecting the null when you shouldn't, or erroneously concluding that you have a result when you probably don't. The questions that we can answer with this that were of interest to us is what constructs or what predictors or ideas separate the countries in terms of math teacher preparation. How many of them do and which ones? And so that's why this form of analysis was useful to us. And again, the formula to the right is basically the linear function. So we get several different functions when we run the analysis, and we pick the one that means the most. Instead of means, we're going to be talking about centroids. So centroids can be considered a multivariate form of means that we're comparing when we look at country differences later on. Any questions so far? Okay, so our research questions. Are there mean differences or centroid differences among the 6 countries and some composite outcome? If so, where are they coming from? So what you'll see here is a visualization or illustration of our model, our statistical model, where we have the predictor of countries. So we're looking at the correlation or the shared variance, the proportion of shared variance between the predictor country and some synthetic outcome variable that's made up of different things that we're plugging into the model. So we're hypothesizing that the outcome variable is math teacher preparation, which is composed of math coursework that teachers take, math pedagogy coursework, and general pedagogy coursework. So this first variable is just basic subject matter content. And you'll see down here, these are some of the variables that were included. So history of mathematics, linear algebra, number theory. So basically these were dichotomized in the data set, and we gave 0s and 1s to the values for each case. And so if a future teacher took this course, they got the score for it. We made a composite sum score for every teacher. And we did the same for math pedagogy, which included methods of solving school mathematics problems, math curricula in schools, and so forth. And then the same for general pedagogy. So each of these are now continuous sum scores for each teacher. And we're hypothesizing that these will contribute to this latent idea or this latent variable of math teacher preparation. What DDA allows us to do is figure out how much does each of these observed variables contribute to this outcome variable. And then we look at the relationship between the synthetic outcome variable and the predictor. Okay, so one thing about data visualization is it can make some results like this a lot more digestible, like we said earlier. So someone who's a novice to statistics wouldn't understand how to read this table in a report. And so later on, we'll have some visuals that kind of make this easier to understand. So the first thing we want to look for is, were we able to find statistically significant group difference? And so where we look for that is function 1 through 3, which is our overall solution. We're saying across all the different linear combinations, did we have a statistically significant result? Meaning, were we able to find differences across the 6 countries? And because this is less than 0.05, we can say, yes, we do. So that's exciting. Then we look at the canonical correlations for each function to basically say which function explained the most variance in the solution. And function 1 was the best one. You can include and interpret as many functions as you want, but typically we stop when we start to see negligible variance explained. So function 1 had a squared canonical correlation, meaning a correlation of correlations across all those variables of 0.372, meaning 37.2% of variance between countries, and our synthetic outcome variable was shared. It's not huge, and in fact, it's a little bit weak, but it's still something to explore. And then we want to find out, now that we have a difference and we know it's statistically significant and there is some effect, where is that coming from? So again, analogous to multiple regression, we have our standardized coefficient weights that are assigned by SPSS. And we also have a backup way to interpret the structure of the relationship. So we know that the most weight was assigned to math coursework. So basically this is saying that the actual subject matter that teachers took mattered more in separating countries, as opposed to math pedagogy and general pedagogy. When we look at the squared structure coefficient here, we see that math coursework made up 89.9% of, if I can go back, of this synthetic outcome variable. And then it's very negligible after that in terms of math pedagogy and general pedagogy. And again, this is just for function 1. Okay, so this visual here is basically just the diagram that shows the relationship, the shared variance between the observed predictor and the synthetic outcome variable. And then it also has the weights plotted here. One thing that I wanted to go back and show you, sorry, is that because these structure coefficients for math pedagogy and general pedagogy are close to 0, and the coefficient signs are reversed, it points to some possible suppression effects, meaning that these variables, they don't contribute to creating that latent variable, but they help math coursework do a better job in predicting group differences. Okay, so some of the automatic output that SPSS gives you when you run this analysis is this kind of plot here. And this is similar to what you might find when you do machine learning and k-nearest neighbors, and you want to basically show the separation of the groups in a plot. So again, we looked at function 1. Function 1 is comprised mostly of math teacher coursework. So as I move over in this right direction, we see that people on this side did a better job of providing, or those teachers had a higher level of math coursework. But it's very hard to distinguish with all these overlapping colors. You can barely read the country names. And so all this data is represented here. So on the right-hand side, I just produced this in Excel with the standardized coefficients. And so in the centroids, so the centroids here, sorry, those are also detailed with the 95% confidence intervals. So we can see if we have overlap, these countries are not statistically significantly different from each other on that function 1 synthetic variable. So Germany and Mexico are very similar in terms of the amount of math coursework teachers have taken, but the US is statistically significantly higher than those, but not very different than South Korea, which is surprising to us based on student achievement in that area. So basically showing us that our model doesn't tell us everything. And then we also see that Bulgaria has statistically significantly higher values than South Korea, but Bulgaria does not perform as well in terms of student outcomes on the TIMSS and the PISA. And then Taiwan is higher than everyone, and also the students perform better. So that's consistent. So this is just something to unpack as we go forward. And Milushka is going to talk about some of the qualitative differences in the educational systems and cultures that may also be contributing to that.
Yeah, so hi.
Oh, not yet.
Okay, go right ahead.
Sorry, that did sound like a kickoff. And then, so now that we see the statistically significant difference of the countries, this also provides, it's a matrix of, another way to kind of visualize data of the Cohen's-d effect sizes of country differences. And what's interesting here is that Taiwan is, has a large effect in terms of the standard deviations higher than they are of other countries in every single case. Bulgaria has, well, outperforms other countries as well in some of the cases. But the key here is that Taiwan is doing something that's very different than everyone else. Okay. And some limitations. So again, we talked about the representative nature of the samples, and that wasn't clear across the board that all countries have the same types of institutions involved and the same types of teachers involved or future teachers involved. The time frame of the research, it was a lot older, so some of this may not hold up today, and our data did not link to student outcomes as well. Okay. And now Milushka, take it away.
Hi. Okay, so in order to really understand the data and the analysis that Genéa just discussed, I think it's important to understand the differences and similarities across these 6 different nations so that we can contextualize what we're talking about. And just a little bit of background, most of the information that's presented here is based on the first chapter of Teacher Education Matters, a study of middle school mathematics teacher preparation in 6 countries by Schmidt in 2011. So what the chapter did was it kind of presented a day in the life of 6 middle school mathematics teachers from these 6 different countries. And these are the teachers that we see here. And what we did is that we used the information presented in this chapter to kind of learn more about each country's cultural organizational approaches, and not just relation to teaching, but teaching preparation specifically. So, and Genéa, if you could go to the next slide. So, across the 6 countries, we see some trends. For example, teacher responsibilities usually transcend academic responsibilities. Although we will, if you see here on the left-hand side, the additional duties, the responsibilities, the duties are quite varied. For the most part, we also see that the teaching profession is highly regarded, despite some pretty profound differences in salaries or employment opportunities, as you can see here as well. Teachers spend countless hours performing many duties, most of the times actually unpaid. So let's just kind of briefly review the differences across these 6 different countries. And I'm going to follow some sort of geographical order. So we have Asia, we have Europe, and then we have the Americas. So to begin with Bulgaria, in addition to teaching content classes in content areas, teachers usually take on administrative and organizational roles in school. For example, they're in charge of conflict resolution among students who may be having problems. Teacher unions are fairly active, and despite limited opportunities for professional development, they are able to convene twice or even 3 times per year. We do know, however, that the organizations that offer informal professional development opportunities meet more often, meet on a monthly basis, for example. And these organizations discuss a number of topics: curriculum, resources, teaching materials. However, the chapter spoke about how, due to the lack of school funds, many opportunities for professional development are becoming more rare in the last few years. And this kind of touches upon the fact that a lot of teachers and students generally are contending with limited financial resources. They gave examples of limited IT support, outdated equipment, and in some cases, no access to the internet, no access to academic articles. So quite variable. You see in Bulgaria specifically that despite lower salaries, teacher is actually very highly regarded. And they also have job security, but there are a lot of vacancies for mathematics teachers across main cities throughout the academic year. So these positions are up many times without anyone really filling them. In terms of students, it's kind of interesting how the middle school system is and how you progress to high school. For them to be accepted into a profile-oriented school, which has a reputation of simply being a better school, so these are schools that are usually focused on mathematics or foreign language, students must perform well in these standardized exams, national exams. About half of the 7th graders take these exams, so 45%, and the majority of them pass. So that's a good 95%. The situation is quite different in Germany because we see that securing a job as a mathematics teacher is difficult, and there are fewer vacancies when you compare this to the situation in Bulgaria. The middle school system has a 3-tiered middle system where students can be placed into 3 different tracks. And this is depending on teacher assessments and students' intellectual abilities. And due to the economic problems within the country, within Germany, we see that students who are in the intermediate track of middle school many times have difficulty securing high-quality vocational training positions. So it kind of follows you along. Placement into a specific track usually determines whether the student will go to university or if they're prepared to go into a white-collar job. So you really see the students are being funneled into certain positions. German federal states have mandated exams. They cause a lot of anxiety. They cause a lot of frustration among students and teachers, mostly because of the breadth of the curriculum. So, and this is not unlike many other countries, including the US. Teachers have difficulty simply getting through the curriculum despite efforts to accelerate their learning. And, you know, due to the economic changes that I spoke about before, changes are being implemented to the curriculum and to the structure of middle schools. They spoke about having 2 different systems, AM and PM. Overall, however, we see that learning approaches, diverse learning opportunities, and time allocation are all topics that are receiving a lot of attention in Germany. So we kind of go from Europe to Asia. In the South Korean government ensures that there's a balanced ratio between available slots and the number of positions for mathematics teachers, which makes securing employment a lot easier. However, if you want to secure employment in a really competitive school, you have to score in the upper percentiles of a test called the Secondary School Teacher Selection Tests. And even though you see that you can still secure these competitive positions, perceptions of teaching have changed in the country. It's still, education in itself is still highly regarded, but not as much in comparison to past decades. Now, teachers' responsibilities go beyond teaching. They include, and I thought that this was super comprehensive, they include classroom cleaning, supervising extracurricular activities, disciplining students, ensuring students maintain good hygiene. So you see it's a lot more broad compared to the other countries. School culture in South Korea usually encourages teachers to work past their paid hours, and I feel like this is fairly common. Admission to high schools are, and this is very different, admissions to high schools are decided based on the lottery system. And the reason for why they do this is to mitigate potential differences across the schools. We also know that 9th grade examinations determine students' academic trajectory, because scores will decide whether students will follow either an academic, a technical, or a vocational track in high school. So you tend to see that there's a lot of anxiety associated with these exams as well. And then we have Taiwan, and I feel like Taiwan really stands as the anomaly within this group of countries that we looked at. Teachers' responsibilities, in addition to teaching their content areas, include administrative tasks, dealing with student discipline, even family issues in some cases. They don't just teach their content area, many times they teach other content areas. Teaching professions are pretty well paid in Taiwan. Teacher's salary in Taiwan actually exceeds the average income. And I think that you can see that hand in hand with the quality of education that the students receive. Even while they're on break, as a matter of fact, in some institutions, there is pressure for students to attend school sessions, receive tutoring. They mentioned how also tutoring is very well paid. So the teaching profession overall doing very well. The typical.
Sorry, can I interject? Sorry. I feel like tutoring is a big part of the culture there as well, in terms of just outside of like private tutoring. Would you
Yeah, private.
For students, in terms of like student investment or family investment in the country, compared to if we're looking at distinctions with the US, it's like, you definitely aren't comparing apples to apples.
Yeah, very much so. You know, I read a little bit more about Taiwan and how invested they really were in these exams and how invested they are in education from very early on. And the money that is really funneled, they said a lot of people like spend their lifetime savings on their children's education. So I feel like that's pretty profound. We usually, in terms of students and their acceptance rate to high school, so high school's 10th, 11th, and 12th grade, students are usually placed within a cohort in the beginning of their 7th year, and they remain with that group of students for the next 3 years. Now, admission to high school traditionally relies on student scores on the National High School Entrance Exam. However, a small percentage of students can still gain admission through school recommendations. High school and college placement is pretty much contingent upon national entrance exams. Mathematics, particularly important for entrance. And teachers, students, all of them feel a lot of pressure to spend extra time preparing, hence the tutoring, hence the money that is being funneled. So if we kind of move along to the Americas, we have a somewhat different picture. So if we look at Mexico, the national examinations in the 9th grade decide whether students will attend either general upper secondary, vocational upper secondary, or technical secondary school. Approximately half of the students end their formal education in 9th grade. Quite different from what I was just talking about when I was describing Taiwan. Textbooks provided by the government usually include additional resources, for example, teacher's guides, which reduce preparation time. And resources are quite variable across schools. Some schools have electronic resources, internet access, others don't even have the most basic supplies. So if you're teaching in a poorly funded school, teachers actually tend to incur some of these costs, like the materials and the supplies. And for this specific teacher in Mexico, they talked a lot about time constraints due to typically overloaded schedules. And this includes instructional hours, that extend all the way to the evening. They show the schedule, and some of them go up to like 8 p.m., 9 p.m. And they really overwhelm teachers, limiting the ability to interact with other teachers, with administrators, school board members, and with their own students. And then last but not least, we have the United States, which we know a lot about. Class placement, and we're talking about middle school here, relies not only on students' grades, but also on teachers' recommendations, standardized exams, and in some cases even parents' requests. Unfortunately, the percentage of students obtaining passing scores in standardized mathematics assessments determines financial funding, in some cases mandated school closure, and this is because of No Child Left Behind, enacted in 2001. And these federal legislations, like No Child Left Behind, that require teachers to be certified in the subjects that they teach, have created a shortage of teachers prepared to teach middle school mathematics. Salaries for teachers, despite all the perks that people might think teachers have, are not very competitive. As a matter of fact, required continuing ed courses to maintain state-issued teaching licenses, PD meetings, professional development meetings, meetings with administrators, larger class sizes, and really unpaid hours pose a number of challenges for these students. Generally, though, what we are seeing, and this is just across the nation in the US, and I think it's not unusual in the times that we're living in, the United States has begun strengthening their kindergarten to 12th grade mathematics curriculum. And we are seeing, I guess we're seeing some of those changes. So Genéa, we can go to the next.
Hey, all right. So we're gonna shift the focus a little bit because we're gonna talk about the Tableau data visualization that we built last year for the T-STEM conference in Austin. So the audience in the T-STEM conference are mostly STEAM academies teachers, instructional coaches, principals, or district administrator coordinators. So we're really speaking with the practitioners who are, actively working in the classroom settings or in the district level. So we've taken a slightly different approach when we were talking to these audience, because we really want to focus on storytelling with the data set. So what we did is we built a interactive dashboards in Tableau, and then we also have a story component that Genéa and I had presented to the audience. We divided them up, having them sort of role play reading a particular story of a teacher in a particular countries, and then have them share out. So there were interactive part that allows them to collaborate with each other. And then also we showed the Tableau display at the end, and then also let them navigate with some of the guided questions that we developed for them. So before we build this dashboard, we had to consider a couple of things that we were dealing with. So within that resource that we showed you earlier from the book, there is a focus on a construct called opportunity to learn. So this construct really focus on the teacher's existing coursework and preparation, as far as the math content knowledge, the pedagogy knowledge in a general classroom setting, and also within the math domain, and also their own personal beliefs. So their belief system as far as, math content and different pedagogy approach. Keep in mind, there are different scales of each of these domains that we're gonna look at. Within each domain, there are also different sets of measures. So let's take a look. So we have built 5 different dashboards. So I just want to give you a quick overview of the information that we're presenting here first. So within the first dashboard, we're looking at 2 major domains here, which is the math content knowledge and also the pedagogy knowledge. You don't have to memorize all these. You will actually see these variables in the presentation of the Tableau later on. But I just want to get you oriented before you, look at the visualization and see how things are related. So again, these are the measures such as algebra, function, number, geometry, data. These are the measures that falls within the math content knowledge domain, which is again part of the first dashboard that we're going to be looking at. The second dashboard is slightly different because for that domain, there's only one measure, which is basically a score on the general pedagogy scales. So we utilize a map to show some of the comparison. The third dashboard here now goes into the personal beliefs. So these are, again, the measures that the researcher was interested in assessing the teacher's professional beliefs about math skills, math reasoning, again, within a larger constructs, their opportunities to learn with this subdomains. So next, please. So there's another set of dashboards that we'll quickly look over as well. So these are different than what we looked at in the previous slides. Instead of focusing on the content knowledge and the pedagogical knowledge, these are more of the teacher's own personal beliefs and, you know, philosophy about what they think is a better instructional approach as far as using group work or constructivism's approach versus a traditional, you know, lecture type of approaches. So if you're ready, we'll go into the Tableau dashboard. So we have a tiny CC link here. Make sure you follow the caps in order to get to that. But since we don't have enough time to go into the details, I will be sharing with you the dashboard on my side here. Okay, so let's see. All right. Get to this. Okay. So can everyone see the dashboard? Because Tableau takes a second to load. Sometimes you might see a blank screen. Thumbs up.
Everything.
Okay, great. Thank you. So this is the first dashboard that I have mentioned. So what we want to look at here is, again, with the, you know, with the participant in the room, we give them guided question and we let them interact with these information. So the first thing that we want to look at on this first dashboard is looking at the country comparison. So we organize the measures within the country. So you can see on the left-hand side, we have organized each of the individual measure per country. And then if I want to select to compare a specific country, I can use the navigation on the right here to check or uncheck each of the countries. So for example, the first question, I want to get an overall comparison. Just looking at the first part here on the top of the first dashboard, which country seems to have a higher measures of math content knowledge compared to the other ones? And also keep in mind, for us, when we built this dashboard, we kept the US as a reference. So you don't see United States listed as an option, but you can notice is every chart has a line that falls either on a 0 or another scale. So that is basically the reference line that we're using to represent the US. In another sense, we're looking at data points in comparison to other countries as well as to the US. Any questions so far? Okay. So let me give you guys a second to take a look at the vis here. So how does the countries compare to each other as far as math content?
I have one question.
Yes.
So on your x-axis, what is representing?
Oh, so these are the coefficients that was derived from the multi-level analysis. So the multi-level analysis was analyzing these measures within each of the domain, comparing the measures and also at the country level.
Okay, thank you.
Any other questions? No? All right, so just, you know, take a quick look. It looks like for the South Korea and the Taiwan, these two countries really clustering on the higher end of the measures. So what it represents is telling us that majority of the teachers represented by South Korean and Taiwan, they seems to have a higher level of math content knowledge comparatively to these other countries, as well as comparing to the US. All right, so I'm gonna navigate.
In relation to opportunities to learn,
before you navigate, can you hover one of those little squares. I just want to see what, okay, yeah.
Yes.
Okay, thank you.
Yeah, so that's actually a very good point of the using the viz. You can actually hover over the data point in order to see more specific information. If looking at the scale and try to guess what is the exact value is difficult.
Right. Thank you.
Let me see. So I'm going to just show you quickly.
Can I just, Cary?
Yes.
The last dashboard, that's focusing on opportunities to learn within those dimensions, correct?
Right.
Okay.
Yeah, so for example, if we look at dashboard 3 real quick, so we construct a slightly different chart just to give our audience a different view of the data as well, because we really want to describe what has happened to them versus, you know, throwing them at all these higher level statistic analysis that, you know, that was conducted in order to draw these information. We want them to be able to see visually how does these number fall within the scale. So Genéa, what was your question again? Sorry, I don't know if I addressed that.
Oh, Cary, I was just curious on these dashboards. So 0 kind of represents the United States, essentially,
Yes.
relative to the...
Okay. All right. So I'm going to move on to the 4th dashboard just so we can see the personal beliefs of the teacher. So here is another examples of assessing the teacher's beliefs. So within this chart, this is slightly different because there's actually no values below 0. So in this sense, the chart represents all the values that is above the US. So US serving again as a 0 reference line here, and how the belief system fall for the different countries among these different measures. And then they also have different types of classroom management beliefs. We can see that for consequences type of classroom management beliefs is much stronger in some countries, such as South Korea and Taiwan, versus Germany and Mexico or Bulgaria. So, you know, going back to that story that Milushka was trying to tell us earlier about how some of the systematic differences among the country and how teachers view the roles and also the way they organize students' activities differently, these numbers kind of tie back to that story that we described earlier. So quickly, going over the last dashboard.
Cary, sorry, I have one question. Could you go back?
Mm-hmm.
Could you hover over the, and that top graph, the teacher address, just to show what that full item was again? Teacher addresses. The very bottom of the, under the 0 line.
Oh, there's no value underneath.
Oh no, what does it say? Teacher addresses what?
Oh, this one. Okay, so here's
Okay, I was noticing that Taiwan was a lot higher on that one too.
So
I think it had to do with addressing if somebody had the wrong answer or something.
Yeah, so that's why we had that PowerPoint earlier to show some of these. So one of the issues when the variable name was really long, then it kind of got cropped in this. Yeah, but when we go to the all domains, we can actually see all the measures names again.
Again, okay.
Yeah. All right.
I like that classroom management beliefs chart. That's really informative.
Yeah, so some of these, again, you know, we're trying to give the teachers and the principal a quick visuals of, you know, what we're comparing here, instead of giving them a chart of numbers, you know, in order to figure out what they're looking at. So this really means to reduce the, you know, the barriers in order to make good understanding of the numbers. All right, so this is the last dashboards, again, focusing on the teacher professional belief systems. And again, we see that most of the countries seems to be using, you know, both approaches. And again, the US is served as a 0 here. So we are assuming that the US, you know, utilize both approach evenly. However, in some countries, it seems like that they're really focusing more on the lecture traditional approach, such as Taiwan and the Bulgaria. But again, keep in mind, as Genéa was saying earlier, you know, this data set has been collected at least more than 10 years ago. And so sometimes with, you know, different policy and changes, their belief system and the teaching approach might have drastically changed as far as what it looks like nowadays. So the last dashboard is to allow the participant to really look at all the measures together. So on the bottom here, they could scroll through to look at each country. And then on the right navigation bars here, allow them to select individual countries and also the individual measures. So earlier, we were talking about, so this is the term it looks like, Genéa, teacher addresses. Yeah, that was just a variable name itself. But we do want to let the participant know, because one of the issue with these numbers is they were all on a different scale at first. So ideally, it's really not best practice to put them all together on the same page to compare them, because they all came from a different scales. But again, we're talking with principal just to let them sort of play with this, to compare values that they're interested in. We kind of position ourselves as saying this is a quick viz to look at the different values and be able to compare them, you know, in a quick way. But if they want to tell if there are any significant differences, then we have to go back to our statistic and we have to go back to our result to really truly tell if they are significantly different to each other.
Hey, Cary, could you go back to the map dashboard? I think it's 2.
Yes.
Okay. I don't know if we got to do this one.
Yeah, so we were just showing this, I think, where you were asking another questions. So this is just a map of showing the location of each of the country. And again, for this domain, there was only one measure, which is general pedagogical knowledge. In here, we then have, again, the US plotted, because US is considered the reference line here, serving as zeros. Okay. If there's no question, we're going to move on to the next.
So what does a negative value imply?
So meaning that when we're assessing their opportunity to learn in relation to the pedagogical knowledge, they are considered lower comparing to the US. So these countries that falls under are the one who has lower general pedagogical knowledge. When we're trying to see, you know, during the training phase as a pre-service teacher, they have less opportunities to learn.
Okay.
Yeah. Okay. Switching back to Genéa.
Okay. Okay, yeah, sure. So this is actually a little bit different from what we have talked about earlier. This is one of the abstracts that the group is planning on presenting a poster. And in this proposed project, we were considering a more stochastic way of measuring the parameters, basically using Bayesian estimation because of the uneven, or I would say uncommon distribution shapes of data available for in the education data, as for example the less number of samples and predicting with a odd shaped distributions. So we used a macro chain Monte Carlo method to predict some of those variables. And so in this particular study, we are using a more generalized survey of Teaching and Learning International Survey on 2018, which was conducted by Organization for Economic Cooperation and Development. It's an international agency with around 48 to 49 countries all over the world. And so I'm going to show you some of the preliminary or maybe the demography of the data set that we got from the survey of 2018. Genéa, can you move to the next one? Okay, so here we have actually just a rough idea about the data set and some of the comparisons with the countries. So altogether, there are 3 different levels of sub data sets. So we are only concentrating on lower secondary school level, and it is not only math teachers, it's more general or overall teachers are included in the sample. And the primary focus on this survey is to study the learning environment and professional development and the working condition of teachers in those schools around 49 countries. And there are 2 levels of this survey. One level actually goes to the ground level, which is the individual teachers. And then the upper hierarchy is the survey from the principals or the schools. They all actually confirm that all the schools around the countries have followed a standardized method of sampling and survey data distribution. If the criteria is not met with the international standards, the survey did not include that data set or that sample for the complete survey data set. So this basically provide opportunities for the teachers to more involved in the policy making and policy contributing to the policy making of the schools and education systems, and also the body or the school or in more government level or the federal level, policymakers can compare their approach with other countries. And as for example, here I have show you some of those data extracted from those surveys for the secondary school level. So here we can see the x-axis is the hours per week the teachers spend on their work on the job, and the y-axis is job satisfaction score. This is actually a scaled score which was kind of extracted from their survey answers. They have provided a standardized scaling method to convert all those qualitative survey questions to numerical values so that we can use numerical analysis on that. So, and the color code actually shows the self-efficacy of those individual teachers. Actually, it's an average for each country. Here we can see the US actually has a higher efficacy, but also the job satisfaction score is a little lower than compared to the other countries. Australia here has some kind of a outlier here because their system has a different approach, and the sample size is a little smaller. And also they work pretty high working hours per week compared to the countries like Brazil, Chile, and all those countries, and Finland, of course. And here Sweden has a higher job satisfaction rating, as well as the self-efficacy is a little higher. And Japan is kind of, has a higher work hours. And if you go more deeper into these data sets, we will be able to find out about their professional development approach, and also their involvement in school policy development and educational system, or the managerial responsibilities. Genéa, can you move on to the next one? Okay, so this is actually I took US as just one of the countries to start with. So here we have the few of those converted variables like job satisfaction, self-efficacy, and professional development hours, and also the professional development barriers that they have. So the distributions of the sample is kind of odd-shaped distribution, so that actually we will be able to cope up with that problem with the Markov chain Monte Carlo method. If you move to the next one. So here just a demography of our US data set. So here we have the bar graph, which kind of gives you the count of education level and gender. So the teachers on the secondary, lower secondary level school has a quite a bit higher education level, like 7 is actually the master's level, 6 is bachelor's, and 5 is above high school level. So we can see just a demography of the sample, and here those box plots, actually I made those box plots depending on the job satisfaction of gender, education level, and here I made one of those variables into a categorical variable again to show how the professional development hours actually make the job satisfaction a little bit higher. So you can see in the first box plot, the higher box actually represent the people who are spending at least 1 hour per week for their professional development. As well as, I mean, gender does not have much of a difference, but education level has a drastically kind of a downward trend in the job satisfaction level or job satisfaction score, but the distributions among each education level is quite different. So it's kind of hard for now to estimate any of the other conclusions on that. I guess that's pretty much our initial touch on that survey data for our poster presentation. So Genéa, would you?
That was great. Thank you, Dinuka. We're going to be presenting that hopefully in Connecticut in 2021 in June. Yeah. It was scheduled for this year, but because of COVID-19, they postponed it, and they already gave us like specific dates, and they said we can definitely present. So we're looking forward to that. And we would like to also write a paper based on this as well. So, okay, so here are references, and oh, Dinuka, here you go. So these are basically just take-home references for anyone interested in exploring data on educational statistics internationally, and then learning more about Tableau, or also listening to a really exciting podcast about apples and oranges and international assessment comparisons. That's there for you. And we want to really thank you all, Brent, Dr. Bird, you all have just breathed life into us. And we hope we've made you proud with our first little taste of work here.
Definitely, this is incredible. The team and the individual work that you've all put into this, it shines through with your presentation.
I totally agree.
It's really a complicated topic and question. I mean, there's a lot of variables. So thank you very much for your continued work on it. At this time, we do have some other folks that have joined us along the way. I just open it up for questions. If you do have a question, you can use a space bar on your computer, press it down, and it'll unmute your mic so you can speak.
So I do have one question. Can you hear me?
Yeah.
Yes. Oh, okay. So regarding the 2015 data, you know, the data sets that you started out with, and you were talking about the repository of data that you used. First of all, I want to say very good presentation that you guys gave. I just wonder if there is any other data that's available, a little bit more recent, since that was 2015 and this is 2020. Do you think that there's any other more recent data that you could possibly look at?
Yeah, that the first data set, MT21, that's really, really old. And we've learned so much since toying around with that about what makes a good quality secondary data set as well. It did not have a good user guide, did not explain weights very well. But the TALIS survey, teaching, I can't remember what it stands for, that's 2018 data. And the user guide is so comprehensive and clear, and the sampling methods and procedures are much more reliable. So we'll be able to make good generalizations based on that.
Okay, thank you.
And it included many more countries, from 6 to 49. So.
Oh, nice. Good.
Yeah, and then there's the way that they standardize the questionnaire, like it's really good. Like they consider all the levels that the world can have, and then they're kind of compressed into one standardized levels of education, and then it has, I mean, I think 500 page of report that they basically introduce the data set. So it's more complex.
Nice.
It was
Very
thoughtfully
good.
done.
Yeah.
I had just a comment and a quick question. I love the fact that you tried to really integrate both the quantitative and the qualitative aspects, which is really challenging to do. One thing that jumped out to me when Milushka was kind of describing the cultural, background of the teachers and basically how students progress, onward through their education, is that it seemed to be a pretty common thread that anxiety around examination performance was really across the board. And I wonder if there's some way of quantifying that so you could put it as a variable in the model. And then maybe also I heard that policy like No Child Left Behind itself might actually be some kind of an influencer there. And I don't even know how you would go about, putting something like that in the model, but I was just curious if that's a possibility.
That would be a really interesting addition along with other student variables, I'm sure. And that did strike me while I was reading the chapter and even doing my own research. And we're talking about a bi-directional relationship here, teachers and students, right? And they're all feeding off from each other.
So Milushka, the slide where you were giving us the details regarding how the different countries approach different pedagogies and the amount of time and expectations they have on different areas. I wonder if you thought about this. If you think about the United States, in which we were, your chart showed we were behind on a few things, could the fact that there are so many options that people can choose from in terms of education versus other areas that people can go into to be quote unquote successful, as opposed to in these other countries where you really have a more narrow focus. What impact do you think that might have on what you've seen in the research?
It's interesting that you mentioned that because so I researched more about the German system and how it kind of like just sets you into a specific track and you can't really lead, like the trajectory is very
narrow.
Yeah. And you see kind of similar patterns across with different countries, not to that degree, of course, but I would say that the United States definitely has a myriad of options students can take. And not necessarily, like you just mentioned, with a positive impact. So I'm not sure. It's interesting that you said, I was thinking about it as I was looking through the German system, but I'm not sure. I would like to think that it's not solely a negative impact that it would have. But then I also worry about the other systems that just track their students that way and limiting the options at such an early stage. And I mean, if you think about it as like a cognitive psychologist, you're making decisions without having all these cognitive abilities at this point that will really just leave you in one end and not really let you explore anything else. So you have this high level of commitment without a lot of exploration. So,
yeah. So that was just a question for discussion. I was thinking about that as you were presenting. I just thought I'd throw it out there.
I think a lot about it from a developmental perspective sometimes because I like cognitive psychology and how just the limitations that you have in terms of cognitive abilities at that age and the trajectory that you're really following and how it's just set in stone at that point. So
I feel like there are a lot of differences in how these countries talk about taking tests and I think it gets to your point about, are students motivated to take tests here? Does it mean anything to the families for them to do well on these tests? Most parents in the US probably don't care so much how the students do in terms of like contributing to the aggregate. Because I feel like our tests are more used to determine global things or big picture allocations of resources.
Well, I think it depends on the family itself. I think it's to make a generalization like that because where you have first generation students, you know, that the impact is going to be different from a family where they have a history of, you know, academics in the family. And so I think it's going to vary the circumstances, the environment, and things of that nature.
I think about like when I had to take in Texas, we had something called a TOS test, like 3rd grade and 8th grade. And I don't even think my mother knew I was taking that test or cared what the results were. But I feel like in other countries, it's tied to the student's progression and like opportunities in that country to be able to like get that test, and it means something for your individual portfolio to have access to these other things. But yeah, and
I think I can kind of relate to that as an immigrant. My parents they still to this day don't speak English. Really didn't know and didn't keep up with this because, and I think that there's this narrative here in the United States too that you can pick yourself up even if you, whereas in Peru, for example, if you fail the standardized test in order to gain acceptance into college, that's it. So it's a one-shot deal.
Yeah, that's an interesting point that you make, because with the high school graduation, you know, the goal is to graduate, but like you just said, you can pick yourself up. You can take the GED or something.
Correct. There are all these other options you have.
Exactly. Yeah.
Yeah. Thank you.
Those are all of my questions that I have.
Oh.
Yeah, I was in the chat function, and I guess it was just forwarding space. Sorry about that. I wanted to thank each of you for your continued work, and your effort on this is tremendous. I think it's a question in a lot of people's back of our minds, you know, parents, and they think about the US as we've kind of slid in the global view of, you know, our comparison and how well we're doing. Obviously, like my wife, her parents were both teachers. My mother was a teacher as well in elementary school. And so it's kind of interesting to see how the status of teachers and pay level, yet, you know, they seem to be working more hours for less, I guess, satisfaction. And so it's really sort of at this time in, you know, the way things are growing, I'm just curious to see this kind of research that you're doing hopefully will have some impact on the decision makers and how they might think of readjusting. Hopefully, you know, that's the hope for all the research that we do, right?
Right.
So, you know, continued support to what you're doing, and we'll continue to be in touch as well. So thanks again. And I'll eventually will have a link to the recording, and that way you can share it with folks in your circles as well. So.
Will you also provide a link to the slides? Will you make the slides available?
Yeah, we could do that. If you guys are willing to share those with me, I can put a link there with the YouTube video that you can download those. So
that would be great.
Yeah, all right. All right, thanks again, and continued well wishes for everyone as we go through this unknown time period. But all of you pursuing your degrees, I'm sure that we'll find a way to get everyone to the next stage. So.
Yes, congratulations, you guys, on a very well put together project, and it's great seeing you all.
Great seeing you.
Same here.
Likewise.
Everybody.
Thank you.
Bye.